We present a data-driven safety filter for safe motion planning. In a traditional autonomy stack, the reference trajectory, computed by the motion planner, is passed directly to the tracking controller. However, this reference trajectory may not satisfy desired safety requirements. One solution is to use a safety filter to enforce these requirements. Our proposed safety filter has two steps. First, we compute safe half-spaces. We use a conditional value at risk, or CVaR, risk metric to measure collision risk. We use samples of predicted obstacle motion to estimate the CVaR. Then we wrap this with a distributionally robust optimization formulation to handle out-of-distribution samples. This gives us dr-CVaR safe half-spaces. Next, we formulate an MPC problem to compute a minimally deviating trajectory from the reference. We use the computed safe half-spaces as constraints in the MPC problem. The resulting filter trajectory is guaranteed to satisfy a risk bound despite the lack of knowledge of the underlying prediction sampling distribution. To demonstrate the safe half-spaces, consider an ego robot and an obstacle. The ego has access to sample predictions of where the obstacle may be. This figure shows safe half-spaces using an expected value, CVaR, and dr-CVaR risk metrics. The dr-CVaR half-spaces are the safest and can be relaxed or tightened using a parameter epsilon. The dr-CVaR half-spaces can be computed efficiently for a large number of samples. The solver ECOS can solve the problem in a few milliseconds. This is comparable to the time it takes to compute safe half-spaces with the pure CVaR metric. In these examples, we show the proposed dr-CVaR safety filter in two scenarios, an intersection and a head-on collision. Compared to using safe half-spaces with the expected value or CVaR metrics, the dr-CVaR formulation keeps the ego robot safe, even in edge cases. We also demonstrate the proposed safety filter with multiple obstacles. At each iteration, the ego vehicle computes a safe half-space per obstacle per time step in the MPC horizon. Then, the MPC problem with the dr-CVaR safe half-space constraints is solved. The ego vehicle avoids all three obstacles and safely reaches its goal. For more details, check out our paper, Distributionally Robust CVaR-Based Safety Filtering for Motion Planning in Uncertain Environments.